You will eventually. If we have the fraction 12/16, is that in simplest form? No. What can we divide 12 and 16 both by? Cody?
4.
We can divide them both by 4.
6.
Well, let's just do 4 first. 12 divided by 4 is 3. 16 divided by 4 is 4, giving you 3/4. Is there anything we can divide 3 and 4 both by? No. So that would be in simplest form. Now, if we had the same thing, 12/16. Let's say you didn't realize you could divide them both by 4. They're both even, right? What can we always divide every even number by, Henry? We can divide them both by 2. 12 divided by 2 is 6. 16 divided by 2 is 8, giving you 6/8. We still have even numbers, so we know we can divide them both by what, once again? And that would be 2. So 6 divided by 2 is 3, 8 divided by 2 is 4. Even though we took 2 steps, we still end up with the exact same thing. Okay? Doesn't matter what you divide 12 and 16 both by, as long as you keep reducing it, eventually simplest form will be the exact same every single time. Your paper for me. Now, some of you probably may have already dealt with this, maybe you did not. If we took the problem (3/8) times 4/9. The first thing we would do is we'd multiply 3 times 4, you get 12. And then you take 8 times 9, you get 72. Now, when we look at that, is it in simplest form? Now, what can we divide the 12 and the 72 both by? We can divide them both by 6. It's not real obvious, but we can. Very good. 12 divided by 6 is 2. 72 divided by 6 is 12. The 2 and the 12, we can divide them both by, Keegan?
2.
We can divide them both by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. And we get 1/6. Now, if I gave you the exact same problem, but I said that you can reduce any numerator with any denominator, is there any numerator that we can reduce with any denominator? Red?
Yes, there's 2.
Which one?
There's 4 and 8.
Okay, so that first. We can reduce the 4 and 8. What can we divide both the 4 and the 8 both by? Ted? We can divide it both by 4. Now, what I want you to do, okay, it will eliminate possible careless mistakes. We said we can divide them both by 4. So I want you to think. 4 divided by 4 is 1. 8 divided by 4 is? 8 divided by 4 is? 2. Is there anything else we can reduce? Lily? The 3 and the 9. What can we divide both the 3 and the 9 by? We divide them both by 3. So once again, what we want you to think. 3 divided by 3 is 1. 9 divided by 3 is 3. Now, is there anything else we can reduce? No. We can never reduce 1. So when you have 2 ones on top, we know that we are finished. So now we're going to multiply the new numerators. Top times top is 1. Bottom times bottom is 6. And we end up with the exact same thing. The only thing different is we didn't have to reduce that ugly fraction there. We can reduce much smaller numbers, and it gets us to the same answer. Cody?
Can we do that for every question?
If there's a numerator that you can reduce with a denominator, yes. Okay? So, in your notebooks. Reducing fractions before multiplying. can reduce any numerator with any denominator before you multiply. Four ninths times 3/16. If we don't reduce it, 4 times 3 is 12. 9 times 16. If we do that, very good, 144. Now, you don't recognize what, we know they're both even, right? So we know we can divide them both by 2. 12 divided by 2 is 6. 144 divided by 2 is 72. They're still both even, so we know we can divide them both by, well, let's just go with 2 once again. 6 divided by 2 is 3. 72 divided by 2 is 12. And now the 3 and the 12, we can divide them both by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. Okay? Now, if we took the exact same problem, is there any numerator that we can reduce with a denominator? Cameron? The 4 and the 16, we can divide them both by what? 4. So I want you to think. 4 divided by 4 is 1. 16 divided by 4 is 4. Please be careful to make sure that when you're doing that, you're actually thinking, this divided by this is. Is there anything else we can reduce? Hayden? We can divide them both by? 3 divided by 3 is? 9 divided by 3 is? Is there anything else we can reduce? Nope. So now we multiply. Top times top gives me 1. Bottom times bottom gives me 12. Which, ooh. What?
Yeah, exactly. When you do 12, 144, you can go into 12 times.
Yeah, I know.
That's what I was just not sure.
I'm looking over here. What the heck happened wrong here? Oh gosh. This should have been 36. And then this is 12. I was going to say, hold on, we made a mistake there somewhere. Because they need to be equal. Sorry about that. Going back up here, 72 divided by 2 is 36, not 12. Whew. That looks bad for the camera. I know, gosh. Okay, so anyway, now, when we did it correctly, we ended up with the exact same answer. That is why it's better to reduce it beforehand, so you don't make that careless mistake when reducing larger numbers. Okay? I did that on purpose.
Yeah, you did.
Sure I did. Yeah, sure. Okay? Okay. Yeah, I just want to show you how you can make a mistake by accident. Alright? Okay, let's get out your boards. That's exactly right.
Hi, camera. Hi, camera. Hi, camera. I'm over here.
Okay, real quick. If we have
Because so many people are watching.
2/3 times 1/8. Is there anything that we can reduce? What can we reduce, Cody? Well, the 2 and the what?
8.
What can we divide the 2 and the 8 both by?
2.
Okay, go ahead and do that. And then once you reduce it, multiply it. What's your top times the top, Cody? Okay, so the 2 and the 8, we can divide them both by 2, so you should think 2 divided by 2 is 1, 8 divided by 2 is 4. There's nothing else we can reduce, so we multiply top times top gives me 1. 3 times 4 is 12, giving you 112. Yes?
Are all the answers going to end up being 112?
I doubt it. Just a quinky ding. Okay, so next, 4/5 times 10, 11.
Oh, do you want to stay?
Go ahead and do it yourself. Check reducing code. Check reducing. Sammy, what can we reduce? We can divide them both by? So what do you think 5 divided by 5 is? And then what do you think? 10 divided by 5 is 2. Okay? Is there anything else we can reduce? No. Okay, you can't reduce top with the top. So now we multiply top times top is 8. Bottom times bottom is 11. Giving you 8 11. What did you do? You can't. It's got to be top with the bottom. Okay? Let's do this one. 4 9 times 3 16. I'm telling you, it's a quinky dink.
Maybe that's how it has the 12 versus 2 so much younger.
Okay, you don't believe me? Aluminum.
Guys, serious for Kaylin? Rebecca, be serious? Let me see you reduce though. Kaylin, what can we reduce? We can divide the 4 and the 16 both by what? We can divide them both by 2. 4 divided by 2 is? 16 divided by 2 is? 16 divided by 2 is what? 8. Now, if we did that, is there anything else we can reduce, Michaelin?
Yes.
What?
The 9
Okay. What can we divide 3 and 9 both by?
3.
We can divide them both by 3. 3 divided by 3 is?
1.
9 divided by 3 is?
3.
Is there anything else we can reduce? Jaden? The 2 and the 8. They're still even, right? We can divide them both by what? 2 divided by 2 is? 8 divided by 2 is? 4. Okay? Anything else we can reduce? No. Okay, once you have ones on top, you know you're done. Now you multiply top times top is 1, bottom times bottom is 12, giving you 112. Guys, yes. Yeah, I know.
Can we do like we usually do if we get that more?
What's that?
Can we do it like the regular way?
If you want to, yeah, like I said, it just,
Get that more.
okay. This is just going to prevent you from getting larger numbers. Okay? If we do this, four 15th times 5/6. Once you get used to this, Cody, you'll want to do it this way, though, I'll guarantee you. It was 4:15. Not quite yet. No. I'm not sure where you're making a mistake there. Let me see it again. Check your one reducing. Sears Connor?
Connor?
Sorry, Landon. Those are Joe. Landon, is there anything we can reduce up here?
Yes.
What?
15
We can divide them both by?
3.
We can't divide 5 by 3. 5. What is 5 divided by 5?
1.
What's 15 divided by 5?
3.
Anything else we can reduce? Rebecca,
4 and 6.
divide them both by?
2.
Divide them both by 2. 4 divided by 2 is?
2.
6 divided by 2 is?
3.
Is there anything else we can reduce? Next, so you multiply top times top is 2, bottom times bottom is 9, giving you 2/9. If we have this, three-eighths times 1/3. You need help yourself. 3/8 times 1/3. Anything we can reduce here? Cameron? 3 and a 3, divide them both by 3. Now, I was up here. Anytime you have a top and a bottom that are the same, anytime you have a top and a bottom that are the same, you want to get rid of them right away. That's very easy. You know you can divide them by themselves. 3 divided by 3 is 1. 3 divided by 3 is 1. And now, there's nothing else to reduce, so you multiply top times top is 1, bottom times bottom is 8. Yes? Let's do another one. 2/9 times 4/7. 2 with the 9 or the 2 with the 7. You can't reduce the 4 with the 7 or the 4 with the 9. So there's nothing to reduce, so you just simply multiply. Top times top is 8. Bottom times bottom is 63, giving you 8 over 63. Okay? You're not always going to be able to reduce.
I'm listening to.
Yeah. Okay, you're not always going to be able to reduce. A lot of times you will be able to, but not always. Last one. Three-fourths times 12. Dad, first thing we need to do is what? We need to put the 12 in the fraction, so we make it 12 over 1. Now, is there anything we can reduce? What? The 4 and the 12, we can divide them both by 4. 4 divided by 4 is? 12 divided by 4 is? Is there anything else we can reduce? Nope, so now you multiply top times top is 9, bottom times bottom is 1. Anytime you have a number over 1, it's the whole number of the numerator. 9 over 1 is the same as 9. Okay? Keegan.
At the beginning, I put the 12 over the 1, and then I divided the 12 by the 4 by 2.
You did what?
So at the beginning, I put the 12 over the 1.
So you had 3/4
Yeah.
times 12 over 1, okay?
And then I reduced the 12 and the 4 by 2.
Okay, so that became a 2, and this became a 6. And then you reduced the 2 into 6 again? If you didn't, then you end up with 18 over 2. You have the improper fraction. Give out the top, out the bottom, you still end up with the 9. Okay? Now, what we're going to do for homework today is you're going to be able to probably apply some of this to that. But, what we're going to be doing for homework, if you had I had 3/4 of a pie left over. Now, just pay attention. I'm going to make my pie into a rectangle just because it's easier to demonstrate it. Okay, so I had 3/4 of a pie left over. Okay, so there is my 3/4 of a pie that I had left over. Of this, I ate 1/3 of it for lunch. So what I'm going to do is I'm going to break it into thirds going the other direction. And I ate 1/3 of them. Now, does that look familiar to anything? What does that look like, Landon? Not scaling, but coding. Which was what? And what are we going to? What did we do to solve this, Henry? We multiplied. We took 3/4 times 1/3. Now, is there anything we can reduce? We can reduce what?
Oh, 3.
The 3 divided by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. Now you multiply top times top is 1. Bottom times bottom is 4. And I would have eaten 1/4 of the pie for lunch. Okay? We would have eaten those three pieces, correct? If we took the same pie and we broke it, put it in a different pan, oops, why am I doing that? I would take this piece, put it there, this piece, put it there, this piece, put it there, and now I have 3 out of 12, right? 1, 2, 3 out of 4, 5, 6, 7, 8, 9, 10, 11, 12. If I divide them both by 3, there is my 1/4 of a pie that I had for lunch. Okay? Let's say I had this. Okay, so I had 2/3 of a cake left over. So here's my cake. I had 2/3 of it left over. Of that 2/3, I ate 1/2 of it. So how much did I eat? I ate that right there. How would I find out? What do I need to do? Cody? How would I solve that? Cameron? 2/3 times 1/2. I can reduce the 2's. 2 divided by 2 is 1. 2 divided by 2 is 1. Now multiply top times top is 1. Bottom times bottom is 3. Give me 1/3. If I drew this cake over here, this piece goes here. This piece goes there. That would be 1/3 of the entire cake. Does that make sense? If I had this, I had 3/8 of a pizza left over. I ate 1/3 of it. How much did I eat? How would I solve it? Right?
Are you sure that says 8?
Probably not. I ate 1/3 of it. How would I find out how much I ate? Carolyn? I would multiply. 3/8 times 1/3. Once again, the 3 and the 3 divided both by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. Now I multiply top times top is 1. Bottom times bottom is 8. And I would have eaten 1/8 of the pizza. Now, what do all 3 of these problems have in common? Oh yeah. Looking at the word part of it. What do all 3 of the word problems have in common? And Hayden?
You're multiplying.
Why? What wording is common in all 3 of them? Nope.
How much?
Nope. This. 1/3 of it. 1/2 of it. 1/3 of it. It's a fraction of whatever I had. If I had, the class had 9 pies. They ate 3/4 of it. How much did they eat? Well, here's my 9 pies. They want 3/4 it. So break it into 4 sections, eat 3 of it. Break it into 4 sections, eat 3 of it. Break it into 4 sections, eat 3 of it. Break it into 4 sections, eat 3 of it. Break it into 4 sections, eat 3 of it. Okay, break each one of these pies into 3/4. Okay, so here's 3/4, 3/4, 3/4, 3/4, 3/4, 3/4, 3/4, 3/4. If you add them all up, that would be 27/4. Everybody understand that, how I got the 27/4? It's an improper fraction, so I divide the top by the bottom. 4 goes into 27 6 times. 6 times 4 is 24. Subtract, you get 3. That 3 is your numerator, denominator is 4. It's giving you 6 and 3/4. However, if I just simply take 9 times 3/4, I put that 9 over 1. Is there anything I can reduce? Nope. 9 times 3 is 27. 1 times 4 is 4. That looks pretty similar to what I have there. Henry.
Your work problem says, how much did that eat?
Anyway, don't worry about that. Just get the idea. Okay, great. The point is, once again, it's 3/4 of something. Okay? I mean, we can get in here, we can worry about the English of it, but I'm more worried about the math of it. Okay? So, anytime they ask you to find a fraction of a number, we want to make sure that we're going to multiply them. Okay? Any questions? Okay, your homework. Who's absent over there? God's rich. It's an emergency.
He was drawing on the desk. You bad.
Okay, your homework is questions 1 through 5.